Hydrodynamics is how the peripheral nervous system is capable of getting its level of precision and accuracy, as well as like the random specificity that we can get from it. Now, if you look at like the median nerve and you're trying to see how you can send an electrical signal through and get one back out, especially one that's going to have any sort of information, like if you understand electricity, you understand that that's just not what's going on there. If you look at that as a fluid mechanics system, that is honest, it'll blow you away. You're like, that's a really cool system to have multiplexing for information through pressure back and forth, because you can use pressure, velocity profile, and momentum profiles to get just all sorts of crap. I mean, look at the hand, and it's got like all these like the really tiny parts of the arteries that have all those jagged whatnots. That is so that way you can cut back on velocity and momentum's interference on pressure. If you look at like the palmar artery, that large diameter that doesn't change in cross-sectional area even when its fluid requirements have reduced, if it's the supply, and then you see those curvatures, that is to reduce loss. And so that allows you to have basically feedback that isn't, it's at a low velocity and a low pressure, so that way there's just, it's quick without, basically you can send information quickly without it being affected, like you don't, it can be sensitive, quick, without worrying that you're gonna lose any of the data through increasing the momentum, right? Because increasing the momentum costs money, or cost. So something that like I think scientists or doctors don't really think about is like, if you were to have a cross-sectional area of a pipe, right? You understand that if you double the diameter, the fluid flow gets cut back to a quarter. The pumping power is 1/16. 1/16 the power, all right? 1/4 the velocity, twice the diameter. Let's see, I mean, this answers so many things, right? Think about when you learn something, or like how a baby is flailing and like loses it all comes in very, very specific. That's why our brain, right, the cerebral cortex, it's just a hard drive that honestly can grow in space, which is cool. So what else? I mean, there's like so many. That's how I got the fingerprint theory. This even led me all the way to understand like how and why we sleep, right? Like, and how that's evolutionarily beneficial. But just like, I don't even want to complicate it too much. If you're trying to figure out how the brain does all that it does, understand that you have 60 bits a second or so of conscious resolution. You cannot, like, even if you had the best case scenario, you would have to have some sort of neurobiology somewhere, a controller type thing or a processor type thing that's capable of taking this data and being able to put it into some sort of a waveform. Would have to represent it in some way in which it's simple and consistent. And so how do you figure out like the acceleration of gravity, or the acceleration of like when you apply like your, well, you have these, you have limited degrees of freedom, your skeleton, you have fluid dynamics, and then what happens when you apply an acceleration to a mass, which our blood has mass, which is why our blood is warm, to maintain a specific viscosity, so that way we can get this kind of movement. I mean, this crap just keeps on going. And I'm just watching these people describe anatomy, and I got to a point where I was like, I'm not even gonna follow these names, because they're just, learning the names itself, it will literally take you, it requires so much effort that even I, trying to follow it as a systems engineer, realized that I was just, if I even learned the names, just the fact that I saw things that had what looked like certain consistencies, but just because they had like, the dorsal lateral, this, like the specific location, and it's like completely different in your head now because you gave it a name. It's like if you had a transistor, but instead of calling it, instead of making transistors, and then you go BJT, and MOSFET transistor, NPN, and PNP, like I'm all over the place right now, and I feel like I can't even get this out without speediness, because this just blows so much science. Like, this changes so much stuff. Like, you understand how many questions this answers? It's ridiculous.